So how do you implement a bottom-up parser? So if you remember, we have an input buffer, and we have a stack for our we have already used it in top-down parsing. Here also we have an explicit stack for implementation of a bottom-up parser. So since the main actions of this bottom-up parser are shift and reduce, this bottom-up parser is also known as shift reduce parser. Okay, so the four operations, since we have shift and reduce, like formally there are four operations: shift, reduce, accept, and error. So shift means the parser will shift a particular token or the next token from the input buffer to the parser stack. Reduce operation is the parser reduces the right hand side of a production to its left hand side. Whenever a production is considered, it reduces right hand side to left hand side. So for this we need the handle. The handle, it always appears on top of the stack. So whenever there is handle present in the stack for a reduction, it has to be appearing on the top of the stack. So we have another two obvious actions or operations, that is accept. So parser announces a successful completion of parsing, and whenever there is some error, syntax error occurs, the parser discovers it and throws and does this error operation. So the parser, it gets operated by these actions. That is, first it will start shifting tokens onto the stack, and on the stack you will find a handle, say beta. At the top of the stack, it reduces beta to the left hand side of that particular production where beta is the right hand side. So parsing continues until an error is detected or input is reduced to start symbol. So error detected means it will perform error operation, and if the input is reduced to start symbol means it is you have this accept operation. So shift and reduce are the main two operations, and for ending it you will get to a halt by these two operations, that is accept and error. Let us see an example for this. The input string, suppose it is id plus id star id, and we have this grammar. We already seen this grammar. Here two things to be noted is dollar is used to mark the bottom of the stack. When you consider the stack, the bottom will be identified using the dollar symbol. Bottom will be identified as dollar symbol, as well as in the input buffer, the rightmost end will be marked as dollar again. Okay, so this dollar sign is used for both of that. So we have stack, input, and action. So we will be parsing this id plus id star id using shift reduce parsing. So let us see the first step. We have stack. In the stack we have dollar, which marks it as empty. When you see only dollar as the top of the stack means the stack is empty. And in input we have the whole string id plus id star id, and for the right end marker we have dollar. And when you see this, the first action to be performed is shift. So shift means this first token from or the input pointer points to a particular token, and that token has to be shifted onto the stack. So you can see it in the next step. So id is being shifted. You have plus id star id here, and id, when it gets shifted, it identifies this as a handle. So since you are getting a handle on the top of the stack, so top of the stack means now id is the top of the stack. So since id is a handle, we need to perform a reduce operation. So reduce operation you perform using it has to be using a production where this handle becomes part of the right hand side, and with the left hand side non-terminal, this has to be reduced. So that comes in the next step. Here we have id replaced using f in the stack, and here there is no change in the input. Here we have since f is a handle, for the next step, since f is a handle, you need to reduce using t gives f. Okay, so id is reduced to f. Now f is being identified as a handle. Why? Because F forms the right hand side of a particular production. So you reduce F to T. See, here we have T on top of the stack, and input we have this. Since T is again another handle, at this particular step T is the handle, so T has to be replaced using E for using a reduction operation. That is, using the production, E gives T, reduction has to be performed. So T will be reduced to E. You can see it in the next step. See, in stack you have E, and input we have this. Now E is not a handle, so the only action to be performed is shift. So shift happens for this particular token, that is plus. So plus will be shifted onto the stack. Okay, so you can see plus as the top of the stack, and here in stack again you don't have a handle. So only thing is to do the shifting of the next token from the input. So that is, here it is ID. So which makes it E plus ID, and here it is star and ID. So here, since ID is again, you can identify ID as a handle, ID has to be replaced using replaced with EF with a reduction operation. Okay, the production being used is F gives ID. So ID will be replaced with F. Okay, again the same thing. F is a handle in this particular string, or in the stack you are identifying F as the handle. Okay, you use T gives F production to reduce F to T. Now you have E plus T here, and you don't have a handle here. So if you are not finding a handle, means the next action to be shift. So shifting this star to the stack, so which makes it E plus T star, and again you don't have a handle here. You don't have a handle in the sense when none of these substring E plus T star, the substring of this doesn't make a right hand side of a particular production in the grammar, so that it if it gets replaced, it forms a reverse of a rightmost derivation for this particular string. That is why we are not doing reduction. Now ID gets shifted. So since ID is a handle, it gets replaced using F. So you are using this production, ID gets replaced as F. Okay, now till this point you were getting only one symbol handles. Here we have T star F as the handle. So here we have three symbols. So basically it is a substring of E plus T star F. The whole string you have in this is the substring that qualifies as a handle in this particular step. So you have to replace that string using the left hand side of a particular production, that is T. So you are reducing T star F to T, which makes it E plus T. Now E plus T is the new handle in this particular step, which could be reduced to E. So E plus T gets reduced to E, and since that is the start symbol and that is the only symbol in the stack, you can accept the you can perform the accept operation. So if you notice, all the handles, whenever you find a handle in this particular stack, it always will be at the top of the stack. All the handles will be at the top of the stack. Whatever is in red and underlined are the handles that you identified at each step, and all those forms on the right end. Here right end means it is at top of the stack. Okay, so it is not at all possible for a handle to be within the stack. Like it can be only be available at the right end of the of this particular string, or that at the top of the stack. That is one thing you can notice here. So this is the way you do this shift reduce parsing, and this makes it ID plus ID star ID as a valid string for this particular grammar.